Here we want to find the integral of 1 over 3 plus sine of x plus cosine of x. From trigonometry identities, sine of 2x is 2 tangent x dividing by 1 plus tangent square. The tangent squared is 1 plus tangent square secant square. So sine of x, we can write it as sine of 2 times x over 2. So we get 2 times tangent x over 2 dividing by secant squared of x over 2. Similarly, cosine of 2x is 1 minus tangent square dividing by secant square. So cosine of x will be 1 minus tangent square of x over 2 dividing by secant square of x over 2. Sine of x plus cosine of x. So this is sine of x and this is cosine of x. So we have 2 tangent of x over 2 dividing by secant squared of x over 2 plus 1 minus tangent squared of x over 2 dividing by secant squared of x over 2. Common denominator is secant square, so we have secant square. Then here we get 2 tangent plus 1 minus tangent squared. The integrand is 3, it has 3 plus sine x plus cosine of x. And so now we'll add 3, so it would be 3 plus this expression. 3 is 3 secant square over secant square. So right here we get 3 times secant square, but secant squared is tangent square plus 1. And so we get 3 secant square or 3 tangent square plus 1, and then plus all of this. This right here, this is 3 tangent square plus 3. 3 tangent square minus tangent square is 2 tangent square. And we have 2 tangent x over 2. And then this is 3 times 1, which is 3. And then plus 1, which is 4. And now we can let, now we want this in the integral of this expression. Now we can let u be tangent of x over 2, because the derivative tangent is secant squared. The du dx will be secant square of x over 2, and then we have to multiply by the derivative of x over 2. This is the chain rule. X over 2 is the same as 1/2 times x, so the derivative of 1/2 times x is 1/2. Du will be 1/2 secant squared of x over 2 times dx. Multiply both sides by 2, we get 2 du is equal to secant square of x over 2. And so this integral right here becomes 2u squared plus 2u plus 4. Secant square dx is 2 du. Down here, the common factor is 2. So we can factor our 2. 2 divided by 2 is just 1. So we end up with 1 over u squared plus u plus 2. This integral has quadratic form, so we need to do completing the square. U squared plus u plus 2. This is 1 right here. Take half of 1. Half of 1 is 1/2. 1/2 square is 1/4. So add 1/4 minus 1/4. And then this trinomial right here, the factors are u plus 1/2, u plus 1/2. So that's how we end up with u plus 1/2 square. Negative 1/4 plus 2 is 7/4. This has the form of 1 over u squared plus a squared. So let v squared be u plus 1/2 square, and let a squared be 7/4. So v will be u plus 1/2, a will be the square root of 7/2. And then from here, we get dv over du is 1. And so dv is du. And so this integral right here now becomes 1 over v squared plus a squared, which is 1 over a tangent inverse of v over a. And to go from here to here, we use these formulas right here. The antiderivative 1 over a squared plus z squared is 1 over a tangent inverse of z over a. Here instead of z is v, and so that's why we get v. 8 is the square root of 7/2, and so in the place of a we have the square root of 7/2. V is u plus 1/2, and then u is tangent of x over 2, and this is the answer.